I hope you're having a good week, guys. Okay, so let's get started. All right, when we're solving these, try not to use the calculator where you're getting an angle. That's defeating the purpose. If you figure out an angle and then you can let your answers figure out like which one of these is your answer, that's defeating the purpose, guys. Don't go that route. By the way, a lot of universities call these angle sum formulas, sum or difference formulas. So if you wanted to Google that, that's what you would Google. Any other questions before we get started, guys? If you haven't made really much attempts on the activities, you're probably going to be a little lost. Hope that you're reading the feedback. All right, let's continue. Let's go ahead and do this. Today should be a pretty short day, guys. And let's go ahead and get right into it. So number one, it says, use the appropriate angle sum formulas to simplify the following expression. And I have an expression here. You notice that it says cosine, cosine, sine, sine. So because it says cosine, cosine, sine, sine, that 4x is like an A. That 6x is like a B. That 4x is your A. That 6x is your B. So you look at your formulas, the ones that you've been writing over the last week. And the one that does cosine, cosine, sine, sine is the cosine. And whatever sign that is, it's the opposite of that sign. So it has to be cosine of A plus B. So this is cosine of 4x plus 6x. So you just add them together, and there it is. And that's all you're doing on those. And yeah, it really is that simple. That's it. You're done. Simple, right, guys? All right. Now here comes the fun one. And I'm going to go really slow on this one. So put this on your calendars. Next week, what's you guys, B days? So put this on your calendar. Thursday, you're going to have a quiz. And to get full credit, this is what I want to see, guys. So Thursday, put it on your calendars, quiz on Thursday. Do not use the calculator to get an angle. That defeats the purpose. If you figure out what that angle is and that angle is, then you can just type it into your formula, and then you figure out which one of those answers matches your formula. Don't do that. This is what I want to see for full credit. They tell you that angle X is in quadrant 1. So I draw a little triangle. I say here's angle X. And according to this, cosine is adjacent over hypotenuse, 1, 6. Have I lost anyone? So then from there, I say, okay, I need to figure out what this length is. Why? Because you're going to need it when you expand this guy. So Pythagorean theorem, the hypotenuse is along his leg. That 1 is one of the legs. So this side must be 6 squared minus 1 squared. 6 squared is 36. 1 squared is 1. So this is the square root of 35. And then the square root of 35, I do not think. Yep, square root of 35 does not reduce. There it is. That's it. So you're done with that. And I'm going to change my color to a blue color. Angle Y is in quadrant 4. This is quadrant 4, guys. Use Roman numerals. I know sometimes when I'm typing, I just type the number, but use Roman numerals. That's the proper way. So here's quadrant 4. I'm exaggerating quadrant 4. And I'm going to say here's angle Y. The real angle Y is this one. The real angle Y is, that's the real angle Y. But I'm going to use this as your reference so it could be easier for us. So let's see, that says 1, so 1 right up here because it's adjacent over hypotenuse, and this is 4 right there. I need this leg. So this leg here, Pythagorean theorem, 4 squared minus 1 squared, that's the square root of 15. It does not break down. 15, I guess, 5 times 3? Yeah, it doesn't break down. Leave it alone. All right, and I'm going to go slow, guys. So here we go. They want to know cosine of x plus y. According to your notes, cosine of x plus y is cosine x cosine y minus sine x sine y. You have all of them. Let's see. Cosine x given, it's this one. Cosine y given. So these have been given. Given. Sine x, I can get it. get. I guess I'll just put get. And sine y, I can get it, G-E-T. So how am I going to get those? Well, simple, guys. Sine x, sine is opposite over hypotenuse. I look at the one in red here. So opposite of that is square root of 35 over 6. So this is square root of 35 over 6. I'll put it here on the side. Sine x equals square root of 35 over 6. Opposite over hypotenuse, guys. SOHCAHTOA. All right, the one in blue. I want sine of y. Here's y. Oh, I almost did a mistake, guys. I'm in quadrant 4, so that square root of 15 should be what? Negative, because it's in quadrant 4. The y values are negative. So sine y is square root of negative 15 over 4. I'm ready. And I'm going to try to color code it to the best of my ability. So here we go. I'm ready. So cosine x came from the red one. That's a 1/6. Cosine y came from the blue one. And these are given. That is a 1/4. Minus, and then let's see, sine x came from the red one. Square root of 35 over 6. And then sine of y came from the blue one. Put a negative. Negative square root of 15 over 4. Why are we putting a negative? Because you're in quadrant 4, guys. Any questions so far? All right, we're done pretty much. We just multiply these suckers out. Can I say that word? I think I can, right? That's not a bad word, right? Yeah, 6 times 4, 6, 12, 24. So 1 over 24 plus, because negative times a negative. So you got square root of 35 times square root of 15. So for now, if you're going to use a calculator, I guess you can do it for 35 times 15. 35 times 15, and I got square root of 525. We'll figure out what that is in a little bit. Over 24. Okay. So what is square root of 525? If you have a CAS calculator, I'll give it to you. I think it's like, we'll figure it out right now. If you don't, relax. 25 times something is 525. How do I know that? Because if you have a quarter, how many quarters does it take to get $5.25? 4, 8, 12, 16, 20. So 20 quarters is $5. And then I need one more. So 21 quarters. 25 times 21. There it is. 25 times 21 is 525. And the 25 is a perfect square root. What's the square root of 25? Yeah, that's right, 5. So this whole shebang is nothing more than 5 square root of 21. So rewriting everything, this is 1 over 24 plus 5 square root of 21 over 24. So the denominators are the same, so you can just write 1 plus 5 square root of 21 over 24. And there it is right there. What'd you guys think? Was that super hard? Nah, it wasn't that bad. Life is harder than this. This is just logic. So hopefully you guys are having a fun time here. All right. Oh, by the way, I was looking at UH, the math competition that you guys did. Was it last year? Yeah, last year. No, 2 years ago. And I saw that a lot of you guys right here in this classroom, a lot of you guys placed in Algebra 1 2 years ago, guys. Now, 2 years ago, they were being nice to us because they changed the rules. So we pretty much had all of Algebra 1 to ourselves. But still, you know, we placed. So you guys think you guys can place in Precal? All right. If you log into the website for UH, you'll see all's names on a presentation. So I think that's kind of cool. Maybe put that on your transcript, or not your transcript, on your resume or something, because it's impressive. Or, you know. All right. Anyways, let's continue. All right. Given sine x equals 3/10, and now they tell us that angle x is between 90 and 180. So I'm in quadrant 2. So just over-exaggerate quadrant 2. So there's quadrant 2. And start at the origin. Always start at the origin. There's my reference triangle, not to scale. Angle x is this one. I mean, really, the reality, angle x is really this guy. That's angle x. But we're using that guy to help us out, the interior one, or your reference angle. So angle sine x is 3/10. So I put a 3 here and a 10 there. Sine is opposite over hypotenuse. And then they tell me that let's see, 90 to 180. They tell me that angle Y is between 180 and 270. So 180 and 270, that is quadrant 3. So I exaggerate quadrant 3, and then I just go, and then this is the angle, so put Y right there. There's a negative, group the negative with the Y value, never the hypotenuse. The hypotenuse is never negative. -2 and a 3. And then we're gonna go real slow, guys. We're gonna go real slow. So I'm gonna go back to the triangle in red. So this leg here, this is a negative because it's in the quadrant 2. It's 10 squared minus 3 squared. So 10 squared is 100, 3 squared is 9. So this must be square root of 91. Make sure to put a negative in there, guys. All right, the one in blue. This leg, it must be negative because we're in quadrant 3. And it's 3 squared minus a -2 squared. If you want to get rid of the negative because the one inside the square root, if you want to get rid of the negative because you get confused, that's fine. 3 squared is 9, 2 squared is 4, 9 minus 4 is 5, negative on the outside, square root of 5. Okay, we're ready. I'm going to expand it. Sine x minus y, you can use your cheat sheet. You look at your formulas, and your formula card says this is the same thing as sine x cosine y minus cosine x sine y. I look up here and then I'm going to color code it. Sine x is given to me. That's a 3/10. Cosine y, I do not have that, but I will get it in a little bit. So I'm going to put parenthesis right there. Minus cosine x, I do not have it, but I will get it in a little bit. And then sine y was given to me, -2/3. All right, I'm going to fill it in, guys. I'm going to fill on the cosine y first. So cosine is adjacent over hypotenuse. Here's angle x, adjacent, hypotenuse. Negative square root of 91 over 10. I go to the one, that's the wrong one, huh? You guys got to fix me, guys. I did not do that on purpose. I promise you I did not. That's funny because I even color coded it. All right, I got to look at angle y. Angle y is the one in blue. Adjacent, negative square root of 5 over hypotenuse 3. There. Now it's correct. Sorry, guys. I hope I didn't create headaches there. Okay, now we're looking at the red one, cosine x. Adjacent, negative square root of 91 over hypotenuse 10. Now everything's correct. There's no more errors. At least I didn't see any. All right, let's see what that is. -3 square root of 5 over 30. And let's see, negative times a negative is a positive. I have a negative on the outside, so it's still minus 2 square root of 91 over 30. The denominators are the same. I can probably group them together. They did not group them. I already see it. They did this. 3 goes into 30 10 times. So I'm going to write negative square root of 5 over 10. 2 goes into 30 15 times. Minus square root of 91 over 15. And I look for that, and I think it is, nope, not that one. Sorry, guys, that one. What do you guys think? Not bad, right? And then I put some little message here. Read it when you get a chance. All right, let me come back. So you guys are already back.